Yeah.
Okay, I'm going to show you what the pieces that we have, and then we're going to show a demo here about vector addition. These are our vectors. Notice, for instance, the arrow shows the direction of the vector. That's the vector number. And this is our axes, 0 degrees, 90 degrees, 180, 270. And this is a demo we do with the kids that teaches a couple of different concepts. So notice we have number 1 down here, vector number 1. I don't remember exactly how these all work out. We may have to move some desks and so forth. I don't remember. So we take vector number 1, place it on the grid, and this is our 0 degrees, that direction, 0, 90, 180, 270. It's important the kids do not think about that 0 degrees is an absolute. That direction, if whatever side of your wall that is 0 degrees. I mean, I guess you could even up on the wall, you could even just write 0 degrees, 90 up on the wall, and then that we'd have that as an absolute. It's kind of like north is always north. So we lay this on the grid, and that's 220 degrees of that distance, whatever it is. We take number 2. I'm just going to do these in order this time. Actually, if someone could hand those to me, we'd probably speed things up there. So I'm going to put this right underneath to where it lands right there. Okay, and now let's look at it. It says 2 is at 90 degrees, which is that direction. Now, some kids will do this. They will take this and they will lay it like this, thinking that that's 0 degrees. That's a relative angle. We are using absolute angles. It's not relative to the last vector. It's always 0, 90, 180. If you have kids put these down, you know, maybe do the first one yourself, and then after that let the kids do it, you can already see that mistake. So put that underneath to where that's our landing point. Notice both 0 degrees are that direction. Vector number 2 goes straight up at 90 degrees. Then we put vector 3 underneath. Vector 3. Now again, 0 is that way the entire time. There we go. Vector 4. Again, 0 degrees this direction. I need to run out of room, so I'm going to make room real quickly. Vector 4 goes this way. Vector 5, again, with 0 degrees, still to that wall. Vector 5, again, we're going to run out of space. Let's see if we can get over here. Yep, we just got lucky. There's vector 5. So, again, if you've seen my homework 2, it talks about crazy and lazy. Crazy goes this way, then crazy keeps this crazy path, and crazy lands here at the end of vector 5. His friend lazy starts at the original point and walks straight to lazy, or straight to crazy. Notice we have this worked out to where my finger points straight to the end. This is our result of all of that motion. That's pretty simple. But now, if I give those same squares to the kids and we do it in a different order, let's see what happens. Someone rescue the finger. I guess I could ask you later to give me the finger, but that would be weird. And we're just going to mix these up however I have them. Oh, number 5 is first. Okay, so I'm going to start up here because I'm thinking that will be right. So, number 5. Again, 0 is that way. Then I'm just going to grab one. Oh, 3 it is. What do I have next? 4. Lots of noise. 4. Again, making sure that my 0 is constantly in the same direction. 4 goes this way. And I'll just grab the last 2 so we can do this easily. Vector 2, both goes straight up. And vector 1 here, 220 degrees. And Crazy has now gone, seemingly, a different direction. However, he has still gone, basically, and again, they're a little bit off because I wasn't exacting, he has gone the same displacement, and if I actually were to put a resultant number under there, the angle would be the same as well. So what did we learn by that? Now we can do this one more time and mix them up and so forth, but if we think through this, that this one right here, number 5, you in a certain direction in the x value, positive x, negative y. Positive x, positive y. Positive y, negative x. Positive y, 0x. Negative x, negative y. And it doesn't matter in which order we add those up, they are going to end up at the same thing, which is that value. So what we learned from this, vector addition can occur in any order. You always get the same resultant. Cut.